Okay, let's just dive right in. We have a listener submission today that, frankly, challenges pretty much every assumption we have about game development.
And not just by a little bit. This comes from a community that's already operating at the extremes. Right?
Exactly. They build projects for super optimized web browsers. Everything has to be under 100 kilobytes.
Which is, I mean, that's nothing smaller than a profile picture.
Yeah.
You're thinking, okay, a simple 2D game, maybe some vector art.
Right, a little platformer, a spinning cube, the usual stuff. But this submission, it's a total anomaly. It's a fully 3D autonomous supervillain simulator.
And it clocks in at only 80 kilobytes.
80! It doesn't compute.
No, it creates this, immediate cognitive dissonance. The specs sound like a full-on open-world game, but the whole thing is smaller than a save file.
So that's our mission today. We are going to try and reverse engineer how this digital impossibility even exists. How do you fit an infinite universe in 80 kilobytes?
This is pure engineering wizardry. It's a master class.
And it gets wilder because the creator wasn't just messing around. The ambition here is off the charts. The feature list is something else.
Let's get into that, because each feature is like a direct challenge to how things are normally done.
Okay, first up, the autonomous supervillain AI. This thing isn't on rails. It flies around in space. It picks random stars and planets to go destroy.
And it narrates its story dynamically.
Using text-to-speech, all calculated on the fly. Then there's the seamlessness. You go from deep space right down to a planet's surface and back up again.
0 loading screens.
Not a single one.
And that right there is the first technical hurdle that seems impossible. Normally, to switch from a space scene to a planet scene, you're dumping and loading megabytes of assets.
Textures, models, terrain data.
Yeah. A single low-poly planet model could be several megabytes on its own. The fact that it's instant tells you they're not doing that at all. They're doing something completely different.
And then you land. And there's what they call DBZ-style combat.
So Dragon Ball Z, high-speed, over-the-top action.
Right. The villain can land on any planet, and a local hero is generated to fight it. And then, the grand finale, planetary destruction. The villain flies back into orbit, fires a beam, the planet turns red, and then just explodes into a cloud of particles.
Okay, so just looking at that list, we can already start deducing how they saved space, the TTS, the narration.
Yeah.
That has to be using the browser's built-in speech synthesis API. It's a zero-cost asset. Storing audio files would blow the 80 kilobyte budget instantly.
So the game just tells the browser what to say, and the browser does the heavy lifting.
Exactly. It's piggybacking.
Yeah.
And the combat, it's not going to be some complex physics simulation. It's likely very simple kinematic movement, basic collision. The complexity is in the AI's decisions, not the physics engine.
Right. They figured out they couldn't store anything. They had to calculate everything. And that's the micro-engine magic, isn't it? Procedural generation.
Procedural generation coupled with just ruthless memory management.
So explain that. The planets, the cities, the buildings. None of that is actually in the file.
Not a single byte of it. It's all generated on the fly, only when the villain gets close enough to see it. As it enters the atmosphere, the math kicks in and starts building the world.
But how does it remember the world? If I leave a planet and come back, is it the same?
It is, and that's the deterministic part. Every planet has a unique ID, or coordinates, right? That ID is used as a seed for a pseudo-random number generator.
So the same seed always produces the same result.
Always produces the exact same mountains, the same valleys, the same village layout. It's consistent, but it requires zero storage.
So for someone who's not deep into this, how does math actually build a mountain?
It's surprisingly efficient. You use something like Persian noise or simplex noise. Think of it like this. You feed the function a coordinate in space, an XYZ position.
Okay.
And the function spits out a number, let's say between 0 and 1. If the number's high, like 0.8, the game draws a mountain peak there. If it's low, 0.2, it draws a valley.
So the game is just constantly asking, what's the height right here? And getting a quick mathematical answer.
Precisely. No big data lookup. But the really radical part is the memory cleanup. This engine basically says the whole concept of a persistent scene is too expensive.
And that's the aggressive cleanup you mentioned. Once the villain leaves, the planet's surface is just gone.
Instantly deleted. Nuked from memory. The environment is treated as a temporary visual state, not a persistent place. The camera is like a memory gatekeeper.
A gatekeeper, I like that.
Yeah, because only what's near the villain or the camera is ever held in RAM. Everything else might as well not exist. That's how RAM usage stays microscopic, even with an infinite universe.
Okay, but what's the trade-off? Doesn't that cause, horrible pop-in with things just appearing out of nowhere?
That's a great question. And the answer is managed by the art style. The whole world is low poly, it's abstract. So when things are generated quickly in front of you,
It just looks like part of the aesthetic.
exactly. It looks like a stylistic choice, like the world is assembling itself for you, not like a technical glitch. The low-fidelity visuals are actually a performance feature in disguise.
That's brilliant. But here's the part that really got me. The procedurally generated interiors for every single house.
Yeah, this just takes it to another level. The logic is the same, just on a smaller scale. You enter a house, and the engine uses a different set of procedural rules to instantly build walls, floors, maybe some simple furniture.
And when you leave.
It's gone. Wiped from memory immediately. The doorway is basically a micro-loading screen where the load time is 0 because it's just pure math.
And I'm guessing the same applies to the planet explosion.
Oh, absolutely. That's not a pre-rendered video.
Right.
The color shift is a procedural shader. The particles are a mathematically generated system. The GPU is just told, run these calculations, not play this animation file. The cost is practically nothing.
So the big summary is, 80 kilobit is possible because there are no stored assets, no textures, no models, no audio. It's all algorithm.
100%. It's all math, all the time.
Which brings us to the final, just mind-blowing part of this, the performance. It runs at a flawless 60 frames per second.
On an 8-year-old phone.
Why is this kind of math easier for an old phone to handle than, say, a modern game's assets?
It's all about memory latency. Old hardware has really slow memory buses. Trying to pull huge textures or complex models from storage into video memory is a massive bottleneck.
It gets bogged down.
Right, but these simple repetitive math functions, the CPU can chew through those in its own fast internal cache. By avoiding huge data transfers, the engine keeps the workload right where the old hardware is strongest.
So that camera gatekeeper is the key to the 60 FPS. It keeps the amount of stuff to render and calculate incredibly small at any given moment.
It's a perfect optimization loop. You're never rendering an open world. You're rendering a tiny, constantly changing diorama right in front of you.
Now let's talk about the motivation behind this. The developer apparently built it in a single day.
In a day. Yeah.
And they were inspired by their disappointment with the scale versus the depth of a huge game like Starfield.
And that context just frames this whole thing perfectly. It's such a stark contrast. You have modern AAA games needing hundreds of gigs of storage, top-of-the-line GPUs.
For worlds that are, when you get down to it, mostly static, mostly scripted.
Exactly. They solve the big world problem by throwing massive amounts of pre-made, high-fidelity assets at it, with budget and rendering power.
Whereas this 80 kilobit project solved the infinite world problem with an elegant algorithm.
It's ingenuity over brute force. They achieved infinite, emergent, dynamic scope for basically zero storage cost.
I love the developer's anecdote about it. They said listening to AAA devs talk about open worlds sounded like a kindergarten session about Lego.
It's the perfect analogy. The AAA approach is painstakingly placing millions of beautiful, pre-made Lego blocks by hand. The 80 kilobit engine invented infinite self-assembling Lego bricks that build themselves, fight you, and then vanish when you're done.
It completely flips the script. It's not about asset bloat, it's about algorithmic complexity.
Yep.
So where does it go from here? What's the future for an engine this efficient?
Well, the beauty of it is that adding huge new features costs almost nothing in file size. Imagine they decided to expand it to the size of an old floppy disk.
1.44 megabytes.
Which is still tiny. But it's 18 times bigger than what they have now. That's an enormous amount of space for more code, more rules.
So what could you even fit in that extra space?
Oh, so much. You could add dozens of new procedural rule sets, new planet biomes, complex weather systems, multi-story underground bases that generate on entry. You could dedicate a few hundred kilobytes to a procedural music generator.
So the game would create its own soundtrack on the fly.
Yeah, just simple wave synthesis. And you could make the AI way smarter. Add new villain powers like creating black holes or manipulating gravity. Those are just new math functions and shaders, not massive asset files.
You could add 10 times the gameplay depth for, what, another 20 kilobytes?
Something like that.
Yeah.
And since it's browser-based, the community potential is huge. People could share seeds for cool planets or challenges just by sharing a short line of text.
Which, leads to this kind of funny but also profound thought. If a major studio like Bethesda actually adopted this philosophy,
they could, in theory, release a new, unique open-world game every single day.
The bottleneck would no longer be asset creation. It would be imagination.
It shifts entirely. This project is a blueprint. It shows that the real bottleneck in big games isn't the tech, it's the reliance on these massive static asset libraries. This is what industrial-scale indie AAA could look like.
So after this whole deep dive, the big takeaway is that complexity and scale do not have to equal massive file sizes. Elegant code can absolutely crush resource bloat.
It's proof that knowledge expressed as an efficient algorithm is just infinitely more powerful than throwing terabytes of data at a problem. This little universe is a landmark.
And that leaves us with a final provocative thought for you, the listener. Given that an 80 kilobyte file can generate an infinite dynamic universe that runs at 60 FPS on an ancient phone, you have to ask yourself this next time you look at a 100 plus gigabyte AAA game. How much of that massive file size is actually essential for fun, emerging gameplay, and how much of it is just asset bloat that some clever procedural math could completely replace? Think about that next time you have to clear your hard drive for a new game.